Okay, so today we're going to look at revolving functions around an axis that is not the x-axis or the y-axis. They will still be vertical or horizontal. We will not do any slanted lines. I'm sure it can be done. I do not know how to revolve anything around a slanted line. So everything that we will be revolving will still be either vertical or horizontal, but today we might be revolving around something like y equals 1 or x equals 3 for that. So it's going to change our method slightly, but not very much. Okay. So we can see here I have given you a graph. Find the volume of the solid generated by revolving the region f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. Okay, so we're talking about this region right here. And we are revolving this region around the line y equals 1. Like yesterday, if we revolve this around the x-axis, what would this shape look like? If we revolve this around the x-axis, it'd be sort of circular, but what would it have in the middle of it if you revolved around the x-axis? It would have a hole, right? Because you got all this blank space right here that's not included. That's what we're doing tomorrow, right? So anything that has a hole in the middle of it, we can't do yet. But if I revolve this around the line y equals 1, you can see that my graph will just all, connect to that line y equals 1. So I could think about taking a little vertical section right here, and I could rotate that. That's my radius. And then I could rotate that around the line y equals 1. And this would be a solid figure. It's going to be not quite football-y, a little football-y, but a little bit like a football, but kind of taller, right? So this is what we're looking at. So everything today is still just going to have a capital R, a radius here. There's not going to be any holes in the middle of this graph. So the only thing that's really changing is how we set up our R for this. We are still going to have circles, right? Our cross sections here are circles. So we're still going to have circles. We're still integrating pi r squared. If you're doing this around a horizontal line, we're still going to look at the x-axis. If we're doing a vertical line, we'll look at the y-axis, right, for our limits. Most things are going to be the same. The thing that changes is how we get this capital R of x. Y equals 1 is horizontal, which tells you that this is a dx problem, which is good because everything's in terms of x here anyway. So I have been telling you, whenever you're finding that radius, that you need to look at the top of that little line you drew in and the bottom of that little line. And everything that you did yesterday hit the x-axis or the y-axis, right? So every time that bottom line was 0, right? The bottom of the line or the left side of the line was always 0. But it's not going to be today, okay? So the top of this line hits the parabola, which is my 2 minus x squared. So I'm going to have 2 minus x squared here. But what happens at the bottom of the line? What do we hit here? Just 1. Okay, so today, because we're rotating around lines that are not the x or the y-axis, whenever we find that capital R, it's going to be the place that our little rotation segment hits at the top minus the place that we hit at the bottom. Okay, which kind of makes sense. Like if I'm looking at like 1/2 right here, if I do 2 minus 1/2 squared, that is going to be 2 minus 1/4. That's going to be 1 3/4, more or less right here. I'm a little off, but the length of the radius is not 1 3/4 because we're only going down to 1, right? We got our value, but we got to subtract 1 because we're not going all the way down to the x-axis. We're stopping at 1. Okay. Now, before I do any integration, I would simplify this just a little bit. There's not much to do here, but you've got 2 minus x squared minus 1, so you can take that 2 and that minus 1 and combine them, and you will get 1 minus x squared. And that's really the only piece that's different from yesterday, because now we're going to do everything sort of the same as we were doing yesterday. We're going to have pi integral radius squared, so 1 minus x squared squared. Make sure you have squares in both places, right? Dx. What should I use for my limits here? -1 right here, furthest left, to +1 to the right. Okay, so just like yesterday, you're doing pi radius squared. You use your limits from the x-axis. The only difference is that the radius is a little bit, finding that radius is a little bit different. So we will have, let's expand right here. We will have 1 minus 2x squared minus plus x to the 4th here. And once we expand, we have to integrate. Chandler, what will I get whenever I integrate this? Beautiful. And we'll evaluate that from -1 to 1. And then from here, we're just plugging in. So we got the pi out front. We've got 1 times 1 minus 2/3 times 1 cubed plus 1/5 times 1 to the 5th minus 1 times -1 minus 2/3 times -1 to the 3rd plus 1/5 times -1 to the 5th. FRQ, you could stop. You wouldn't have to simplify any further, but it's just 1, so it's not terrible. Let's keep going. And we're going to have 1 minus 2/3 plus 1/5. And then we'll have -1. Odd power right here, that -1 stays negative, so, but then we got a negative here, so it's going to be plus 2/3 minus 1/5 there. Rather than getting all common denominators or simplifying here, I'd probably distribute my negative here and see if anything cancels, because that would make it easier to combine. So I've got 1 minus 2/3 plus 1/5 plus 1 minus 2/3 plus 1/5. And nothing cancels, but I could, I'm going to put some stuff together. So the 1s put together will give me 2. I'll get 4 minus 4/3 plus 2/5. Now I've got to go common denominators. We're going to have to use 15, so we'll have 30 over 15 minus 20 over 15 plus 6 over 15 there. So we got 30 minus 20 will give me 10, plus 6 will give me 16. So we'll get pi times 16 over 15. They will probably write this as 16 pi over 15. There. Okay, questions? All right. Well, let's move on. Okay. This time, we need to find the volume of the solid generated by revolving the region bounded by y equals x minus 3 to the third, y equals 8, y equals -1, x equals 1, about the line x equals 1. Okay, so the region that we're looking at here is going to be, well, I went down too far, didn't I? Yeah, because we got y equals -1. It's going to be this region. Here. And we are revolving about the line x equals 1. X equals 1 is the vertical line at 1. So we will be taking a little horizontal piece right here, somewhere, anywhere, that's our radius, and we're rotating it around to make our circle. Now, if I'm rotating around a vertical line, is it dy or dx? It is dy. Right here. These are a little trickier because the equation is x equals 1, but that is a vertical line, like a vertical y-axis. So we have to be in terms of y. Now, for most of the things here, it does not matter, but that means my equation needs to be in terms of y. Are all of my equations in terms of y? Are they x equals something that has y's in it? They are not. Because I got this right here. It needs to be solved for the x. So, for that equation, y equals x minus 3 to the third, I need to solve that for the x. Marley, what would I do to solve that for the x? Cube root. Beautiful. So we'll get cube root of y equals x minus 3. And then what would I do? Add that 3. So I've got the cube root of y plus 3 equals x. I would probably do this. I would put my x first. I would probably do y to the 1/3 plus 3 because we're going to have to integrate here. And y to the 1/3 will be easier to integrate than the cube root. Okay, so that is this equation, y to the 1/3. This is plus 3. Is that purple graph right there. So, if I'm looking at my radius, capital R of y, I need to do, whenever it's horizontal, I need to do right minus left. So the right side hits our purple graph right here. Right, that purple graph is always on the right side. And the equation for that is what we just found, which is y to the 1/3 plus 3. Okay. Then the left side of this function is here, or left side of that radius is here. What value do I have on that left side? It's 1 right there. And that second part, because we'll always be rotating around a vertical or horizontal line, for today, that's always going to be a number, a whole number. It's not going to be another equation for that. So I would just simplify a little bit here. Capital R of y is going to equal y to the 1/3 plus 2. Just putting that 3 and that -1 together. So once we have the radius, this is going to make a bunch of circles. We need to add them together with the integral. So we're going to have pi integral of the radius, y to the 1/3 plus 2 squared dy. What are our limits here? Almost -1 to 8, because that lowest part right there, it is a little hard to see with everything going on there, but that would be right here at -1 up to the highest right there is 8. A lot of times this is going to get you far enough. Let's integrate. We're going to treat this one like a free response question. It gets extensive here in a minute, so we'll treat it like a free response question. Let's make sure we can do this, like actually integrate it and at least get our numbers plugged in for this. So before I can integrate, what do I have to do? Expand. Okay, what do I get when I do y to the 1/2 squared? Y to the 2/3. Very good. Plus, I got to do 2 times y to the 1/3, and I have to double it. That's going to give me 4y to the 1/3, and I square the last and get a 4. And that y to the 1/3, when we're squaring it, that might kind of throw you off. But what do you do when you have a power to a power? Multiply. So you're doing 1/3 times 2 over 1, which gives you 2/3 there. All right, it's not that easy to integrate either, because I've got to increase my exponent by 1. Right here. What do I get when I increase 2/3 by 1? Oh, I did it. Why am I doing that today? I'm getting ready to integrate. I'm testing to make sure you guys are paying attention. That's what I'm doing. All right, so we just need a bracket there. We're integrating now, so we don't need the integral symbol. I got to increase my exponent by 1. 2/3 increased by 1. What is it? 5/3, because you're doing 2/3 plus 1. You can't add those together unless they got common denominators. Multiply by 3 on top and bottom. 2/3 plus 3/3 is 5/3. Right, so a lot of little fraction things here. I've got to divide out front by 5/3. If you want to go ahead and do that in your head, that's fine, but I'm gonna do it slow and explain it all just to make sure everybody's with me. All right, got to do the next thing. What do I get when I increase y to the 1/3 by 1? 4/3. And then I have to divide out front by 4/3. And then what do I get when I integrate the 4? 4y. And I'm evaluating this one from -1 to 8. And so right here, dividing fractions, easy as pie. Flip the second, multiply. You're just going to get 3/5 y to the 5/3. Here, I'm doing 4 times 3 over 4, which is just going to cancel those 4's, and I get 3 y to the 4/3 plus 4y, and -1 to 8. So if this is a free response question, we're definitely not simplifying, but we do have to plug the numbers in. So we'll do 3/5 times 8 to the 5/3 plus 3 times 8 to the 4/3 plus 4 times 8 minus 3/5 times -1 to the 5/3 plus 3 times negative 1 to the 4/3 plus 4 times negative 1. Like that. And we'll just stop there because it's a long way to the final answer if you're trying to simplify that. I don't think you're going to see that on a multiple choice where you go. Simplify all the way. Okay, questions there? All right, I got one more I want us to look at. We got to find the volume of the solid generated by revolving the region y equals 4 minus x squared and y equals -5 about the line x equals -5. So y equals -5, that is a horizontal line at -5. That's here. I would highly suggest always sketching a graph for these. If it's not given, which your textbook doesn't really give you the graphs very often. Well, some of those first ones did. I would sketch a graph every time. So this is y equals -5. And then I'm not rotating around y equals -5. I'm rotating around x equals -5, but let's not do that yet. Let's graph y equals 4 minus x squared. Actually, that might be a typo. Let's graph everything and I'll let you know. That might be a typo because I think x equals -5 is going to give us something we can't do yet. We'll see here in a second. Let's graph the rest of this. So we've got 4 minus x squared. That's a parabola that's been flipped over and moved up 4. So you may just kind of know what that looks like, but if you need to, make your little table. Right? If I plug in 0, I get 4. If I plug in 1, I'm going to get 3. So I've got the point 1, 3. If I plug in 2, I'm going to get 4 minus 4, which will give me 0. So 2, 0 right there. If I plug in 3, I get 4 minus 9, which is -5. So that is right here. And then the parabolas are symmetric, so I could know this other part right here. Would look like this. I'm pretty sure I either put the wrong problem here or I have a typo with that x equals -5. And since we can do it by simply just let's turn this into y equals -5. X equals -5, that can be done also, but it's not going to be a problem we know how to do yet because it's going to give us something that has a hole in the middle and we don't know how to do those yet. So we are going to rotate around the line y equals -5. So y equals -5 is this blue line right here. We are taking a vertical strip and we are rotating around that line y equals -5. Okay, and y equals -5 is horizontal. So since this is horizontal, this is going to be a dx problem. Everything's going to be in terms of x's here, which is good because our equations are in terms of x's and we don't have to resolve anything. So what we're going to do, we got to do our capital R of x. And so we're always going to look, this line, what does the top hit? What function do we hit at the top? 4 minus x squared. Okay, then we need to subtract whatever we hit at the bottom. What does my little radius line hit at the bottom? -5. Okay, and since it is a -5, that really becomes like just a +5 there on the end. So I would combine what I can combine here. And 5 and 4 can be put together, and I've got 9 minus x squared. Okay, everybody okay here? So it always works just to do what do I hit at the top minus what do I hit at the bottom. What you're thinking of is like whenever I have like this value right here, this is 4 minus x squared, and then the distance here is 5, and because those would not like need to be added together, right? But it takes care of itself. If you always do what do I hit at the top minus what do I hit at the bottom. If you have a negative value at the bottom that needs to be like added on, you'll have minus a negative and you'll get a plus. So it will work there. So I just always set it up that way. So we got to do pi integral from, what are my limits? -3 to 3. I can see those from my graph right there of 9 minus x squared dx. And let's make this one calculator active for sake of time, because we've already done this a few times today. So if I make this one calculator active, then I can, if I'm looking for a number, here, if I want the exact, like if I want the decimal, I can do 814.301. Or what you can do, because probably on your homework tonight, it's probably going to be exact values. It's probably not going to be the decimal whenever you're checking your answers. Take the pi off. I get 259 over 2, or 259.2, or I could even change it to a fraction, 1296 over 5. So like what the back of the book is probably going to have is going to be 1296 pi over 5. So I want you to do a few of the ones from the homework by hand, but I'm going to let you use the calculator on some of them as well, because it can just really get tedious in figuring all of that out. So your assignment is these 5 problems, 13C, 14D, 18, 21, and 24. I want you to do 2 of them all the way through by hand. And then the others, you can use the calculator to help you out with there. And I'll let you pick, the answer can let you know whether or not you want to attempt that without a calculator, right? If you see 1296 pi over 5, you want to use the calculator on that one. Let's see, 14D. Is going to be 14D is 16 pi. In fact, I'll give you all of them so you don't have to go back in the book for these. 13C is 24 pi square root of 3 over 5. 14D is 16 pi over 3. 18 is 144 pi over 7. 21 is in the stupid back of the book. Gracious. 24's got a crazy answer, but then they do give the decimal on that, so I'm just going to go with the decimal. I'm going to say 24 definitely. Use the calculator on this one. say none of them look that great, but I'd probably go with 14, 18, or 21. I'd do by hand. Yeah, any two. So there are